Okay, now members, let us see another example here. Now here we're going to consider a case when we have two fixed pulleys and then one movable pulley between them. Let us go to this one. A light inextensible string with load of mass 2 kilograms attached at one end. Full stop. The string passes over a fixed pulley and the movable pulley of mass 6 kgs, and again over another fixed pulley, and it has a load of 4 kilograms to the other end. Find the tension in the string, acceleration of these rods there. So you start by drawing or sketching. So you start with a horizontal. This is where our fixed pulleys are going to be. So you see it has one end kilogram and then passes over fixed. So it means that it's going to be like this. It's going to come with the load. It passes over fixed. It comes down. It passes under a movable. Goes back. It passes under. Over a fixed. Then to be having a weight. So that's how we sketch it. Then you put the pulleys. The first fixed one is going to be here. Then the movable is going to be here. Then the other fixed is going to be there. And then the sketch is done. So they're telling us that this side is carrying a certain weight of 2 kilograms. This movable pulley is of 6 kilograms. Then this side is carrying a weight of 4 kilograms. And then the last through with the sketch. Then the rest is just substitute in our things and do the question. Now, because it's the same string, it's going to be having, these are the two fixed pulleys, the movable pulley, then the two weight loads. Okay, first of all, this one is going to be having a weight of 2, the mass times gravity. Also, this one is going to be having a mass 4 times gravity. This one is going to be having a mass 6 times the gravity acting. Then, now, remember we said at the end of the strings, like we saw the other case, at the end of the string, we are going to be having first of all tension in this string, T, then this will be T throughout. I think we explained why we have these two, these tensions in our first lesson. We explained why we have the tension in the string. Now, we said that at the end of the string, this one is having 2 acceleration, this one, because the acceleration are going to be different, because this is 2G and this is 4G. So this one is acceleration 1 and this one is acceleration 2. Why am I using 2? Because it's easier to deal with all numbers than fractions. So we said if this one is 2A and this one is 2A1, it means that now this one is going to be having the acceleration. Now we assume that these ones are going downwards in the same order, like that. Now this one, remember they are going down like this one will be pulled up, because these ones are pulled up by this way and this. So they are going down, then this is going to be going up. But the acceleration of this inside is half the total acceleration of this part at this end and then at this, which will be 2A1 plus 2A2, which you can easily see. The acceleration there in that direction is going to be A1 plus A2. Now, for this particle, I'm using, but you can use 2A2 and then A1. Then this will be a half of A1 and then A2. I'm using just these two to avoid these fractions here. So that's why I'm doubling them here. But it's the same. These are just figures. So we say the acceleration of this is that we are going to be, this one is going to be affected by the acceleration of this and the acceleration. So it's going to be a half of this plus a half of this. When we have 2 to the other end, then we get a half of this plus a half of this. We shall be having the acceleration of this, but in that direction up there. So after doing that, the rest are just solving. Now we consider the 2 kilogram mass. What I have in the 2 kilogram mass, you see acceleration for it is going to be in this direction here. This is 2a1. So remember, our resultant is equal to 2ma. So my resultant is going to be, you see that what is pushing it in this direction is 2d, then minus the opposite, which is t, equal to the mass, which is 2, then times the acceleration, which is 2a1. And from there, it's that my 2b minus t is equal to 4a1. I call this equation 1. Then I come to this on 6. Okay, let's come on a 6 kilogram mass. On a 6 kilogram mass, now from there you see that this one, for it, is acting in this direction, like this. And the acceleration there is going to be a1 plus a2. As if this one is twice, if this one is just a1 and this one is a2, then it's going to be a half. So what is pulling it up in that direction? We have t. Okay, our resultant force is going to be the mass and the acceleration. So we have t, then plus t, then minus this one, which is opposing, going down, then the mass 6, then times the acceleration, which is a1 plus a2. Okay, so after having this, we see that we get 2 minus 6b equaling 6 into a1 plus a2, which we can divide through by 2. We have t minus 3b equaling 3 into a1 plus a2. I call this equation 2. Equation 2, okay. And where I can write, this is our equation 2. Then I come to the 4 kilogram mass. At the 4 kilogram mass, I have my, see that now, for it we are going in this direction, the acceleration is in this direction, but it's 2a2. So our resultant force equaling ma. My resultant in that direction, we have 4b minus t equaling the mass 4 times 2a2, the acceleration. And from there, you see that this one is going to give me 4b minus t equaling to 8a2, and this will be equation 3. Okay, now I have 3 unknowns and I have 3 equations which you can easily solve. So how are you going to do that? You see from here, I have a1, I have a2, and I have t. G is always known. So meaning, what am I going to do? I'm going to come here, make a1 the subject, and I put it here, and I make a2 the subject here, and I put it there, then I'll be having the t. So I'm going to say from 1, okay, I have from here 2b minus t equaling to 4a1. Applying that, my a1 is going to be, when I divide this, I'm going to be having 4 divided here. Okay, I'm going to be having 2b minus t over 4. Then from 3, there, 4b minus t is equaling to 8a2. Imply that now my a2 is going to be equaling to 4b minus t the whole over 8. Now I substitute them here. From 2 is that 9t minus 3b will be equaling to 3 into a1 plus a2. And this substitute them there. So 9t minus 3b will be equaling to 3 into, now my a1, then plus a2 over 8, which you can every simplify. You see this one there is going to be 8, so 3 minus 3b be equaling 3 into 2b, 2 into 2b minus 2, then plus 4b minus t got the LCM. This one goes here, 2 times now this goes here, 1 times that. That's what we have. Okay, simplifying our t minus 3d will be equal to 3 into this is going to be 4d plus 4, that will be 8d. Then minus, this will be 2t minus 2t minus 3 minus 3t, they're all over 8. So if I cross multiply, this side I'll be having, okay, so that we don't skip steps, people may complain. Minus 3d will be equal to 24d minus 9t, the whole over 8, which I can simply cross multiply. 8t minus 24d equal to 24d minus 9t. And I take this side, I'll be having 17t equal to 2. Take this side, I have 48d. So my tension here is going to be 48d over 17. So that will be our tension. So if we have that, which we can happily simplify, I come here, then I get my A2. Okay, starting with my A1 is going to be 2d now minus, remember our t, which is now 48d over 17, the whole over 4. So my A1, simplify it, this is going to be 30. Sorry. Can I take this one? Okay. Our together is going to be, what is it? Is it going to be the reverse? Anyway, when we get our t here, we are going to have this times this. We are going to get 2 times, then minus 48. So we have negative 14d, the whole over is 17. Minus that's 4 over 68, which we can easily get as a, one is going to be negative 14, 9.8 over 68. And you can get our A1 there. Remember, this A1, we need the expression that this we shall just multiply it there. So, for this, because they want us to get the acceleration at this part, which we say is going to be twice A. So, let me write this when I say at. These are going to be meters per second square. So I say at 2 kilogram mass. Our acceleration is going to be 2A1, which will be, when we get now our A1, 2 into negative 14d over 64, which will be, this will be negative 14d over, this will be 32. So that will be the acceleration there, which we can simplify. Then we come for our A2. Okay, our A2, already said, it's going to be, where is our A2? 4d minus t over 8, which will be 4d minus our t, 48 over 17, then the whole over 8. So our 18 here, we shall get 4 times 17. Okay, that will be 20 d over 7 times 8. 17 times 8. acceleration of this particle here, our acceleration here is going to be twice. Now at 4 kilogram, our acceleration, our A is going to be twice A2, which will be twice of this will be 40 g over 186 meters per second. All these are also meters per second. You put your g, you also put your g there. Okay, so after doing that, now we have finished this. We are finished for this. Then we come for this direction here at the 6 kg. Then our acceleration, right, we said it's going to be A1 plus A2, which is going to be our A1 is here. Sorry, our A1 is there. Negative 14 g. The whole over 68, then plus. I think this one, you can also reduce it. You can reduce this by 2. Yeah. I want it to be having the same LCM. So by 2 here we get 10 g. By 2 here we get 68. So then plus 10 g over 68. Acceleration there is going to be negative 4 g over 68 meters per second. What does it mean when we have a negative? It means that now the direction, this one was also being pulled up. Whenever I start this direction, it means that this one was pulled up, because when you pull this one, because it's weight, more having more weight, when you pull it up, down like this, it means it's going to pull this, and then this one is also pulled. That's why I have a negative there. So it means that our A1, so that A2 is positive because the acceleration was going in that direction. The moment that's negative here, means it was going upwards like that. So that's how we handle that. I wish you well be able to interpret or erase those negatives there. So meaning, whenever I say negative acceleration, it means that the acceleration was occurring opposite direction. Opposite to that you stated. So our A19 meaning it was occurring like that. I think you can now read this note here. So that's the idea. Now this one is also this one is negative, so meaning instead of going up, it was going down.